Hi, in this video, we'll explain chapter number 12, mechanical actions. So, first of all, we'll define force. What is a force? I have two bodies, two objects. One object will exert a push or pull, will exert a mechanical action on the second body. We say that we have a force acting from the first body to the second one, or exerted, okay? So, what are the effects of force? A force can make an object in motion. يعني الobject بيكون at rest. Due to this force, the object will be in motion. These are two examples about this effect. The second effect, modify the motion of a moving body. No, here the body بيكون in motion, but due to this force, this motion will be modified. Example, these two figure will show the example about effects of forces, the second effect of force. The third one, the deformation of the shape of a body. يعني due to the force done by the boy on the ball will have a different shape, okay? Another example about this effect. Now we will classify the forces into two categories, into two classes, into two types if we want. First category or first class, contact force. It means force done by the two bodies, but the two bodies should be in contact. يعني لازم يكونوا داقرين ببعض. يعني إذا ما دقروا ببعض ما بيكون في force. Example, muscular force, mechanical force, push. The second type or the second class, force act over a distance. يعني ما ضروري يكون في contact between the objects to have this force. The famous example هي الweight. الweight هي force done by the earth on anybody موجود. The second example, magnetic force, and the electric force is in another example. Now I will introduce the spring balance or dynamometer. هي instrument used to measure the force. يعني to measure the magnitude للforce. يعني قد ايه قيمة هيدي الفورس. First of all, we measure the force in Newton. يعني the unit هي Newton, big N. So we observe here two dynamometer. What is the difference between these two dynamometer? The difference is this number. So if the needle, for example, reach 4, ما بقول أنا عندي 4 نيوتن. بقول the reading of the dynamometer is 4. To know the force, the magnitude of the force, we should multiply this reading by the scale mentioned here. Okay? So here, the magnitude of the force, the reading of the dynamometer is 2. The magnitude of the force is 2 times 5. It's equal to 10 Newton. Now, how can we represent a force? يعني how can we describe a force using what we say vector? Okay? A force is represented by a vector. Sorry. Each vector عنده 4 characteristics. So الvector هي أنا بقول I have the vector F. To describe F, we should mention 4 characteristics. The first characteristic is the point of application. The point of application means where the force is applied on the body. كيف بجاوب على السؤال؟ كيف بقول شو هي point of application? First of all, I ask myself, it's a force, contact force or acting from a distance? إذا كانت contact force, automatically بقول it's the contact point between the two objects. إذا كانت acting from a distance, بقول I have the center of gravity of the body as point of application. I will re-explain in details what we mean by the center of gravity. So here, the boy will push the body of the dog. So it's a contact force. The point of application, it's the point here. Okay. The second characteristic is the line of action. When we ask what is the line of action, we should answer horizontal or vertical or oblique. It means the line holding the force. Here, the line of action is horizontal, but the boy push the dog to the left or to the right. هون بدي precise the direction. So the direction is the sense of the force. It's determined by the arrow of the vector. it can be upward, downward, to the left, to the right, upward to the right, upward to the left. Any word can describe the direction. يعني الفورس من وين لوين, from to. So here the force is to the right. But now قد ايه بدي ارسم هيدا الارم؟ قد ايه قيمة هيدا الفورس؟ The magnitude of the force is the last characteristic. The magnitude of the force is measured by the spring balance, but I can represent it using a scale. For example, here the magnitude of the force is 2 Newton, so I use the scale. Each 1 centimeter will represent 1 Newton. So if I have 2 Newton, how many centimeters I need? It will be equal to 2 Newton. Please pay attention. Here, if I want to mention, so if I want to mention the force, I write F equal to Newton. I cannot write F vector equal to Newton. It's a false written. ليش؟ لأنه ال F vector means إنه I have these 4 characteristics. One of the characteristics of the vector is the magnitude, if it's this notation. But I cannot write F vector equal to Newton. Okay? So now we will move to another point. So weight. Now I will explain كم هيك force in detail. The first force is the weight. The weight is the force done, it's the force of gravity exerts by the earth on a body. يعني نحن كلنا بنلاحظ we fall, نوقع. ليش؟ لأنه الباد في earth في قوة في gravity في الجاذبية عم تشدنا لتحت. So it is the weight. The weight change with the location. يعني my weight on the earth مش هي ذاتها my weight on the moon، لأنه الweight هي force done by the earth يلي هي بتكون بعيدة عن المون. Okay? So the characteristics of the weight, we said that if we want to precise the characteristics, we should mention 4 points. The point of application, since the weight is a force acting from a distance, so the point of application is the center of gravity. Line of action, vertical. Direction, downward, لأنه الأرض دايما عم تشدنا نزول. Magnitude, it's W equal mg. Here I want to mention 1 point. Line of action, it's vertical. Vertical means like this. يعني if I have, for example, this slide, on this slide we have a body, I want to represent the weight of this box. غلط اكتب الويت هيك. No, the weight is vertical. The weight from the center of gravity, I write a vertical line downward. Okay, it's clear? Now, I want to move to another point. What is the center of gravity for some shapes? If I have a circle, the center of gravity at the center of the circle. If I have a rectangle or square, it will be the intersection point of the diagonals. If I have a triangle, it will be the intersection of medians, or what we call centroid. Now, W equal m times g. This is the magnitude of the force. M is the mass of a body. G is the gravitational field length. What is the difference between weight and mass? Before explaining the difference between force and mass, weight and mass, I will solve this exercise. In this exercise, I have a book hooked to the extremity, to the free extremity of the spring balance, G equal 10 Newton per kilogram. Determine the reading of the spring balance. First of all, the reading is 6, but the force is 6 times 10. It will be equal to 60 Newton. Deduce the mass. طب نحن أخذنا أن spring balance will measure the force. طب مين الفورس اللي acting on this body? The force here is a weight. In the second chapter, we'll explain in details what are the forces acting on this body and what is the relation between these two forces. Till now, we say that the force here, the force measured by the spring balance, it's the weight. So 60 Newton will represent the weight. وأنا بعرف إنه الweight will be equal to m times g. So m will be equal W على g. It will be equal to 6 kilogram. In this slide, we observe that the elephant has a big mass, the mouse a small mass, so the gravity or the weight to the elephant will be greater than the weight of the mouse. Now I will compare between the mass and the weight. The weight, it's a force. Force means it's a quantity which has 4 characteristics. It's a vector. It's the line of action, it's vertical. The direction, it's downward. The magnitude, it's equal W equal M times G. بينما الماس no. الماس it's not a vector. يعني أنا بقول my mass it's 60 kilogram. ما بحاجة to determine هال 4 characteristics. It's a scalar. Scalar means it's not a vector. It does not have a direction. The mass represents the quantity of matter containing in a body. يعني أنا لما أقول my mass equal to 60 kilogram, it means أنا فيني matters جواتي كميتهم 60 kilogram. The mass doesn't change with the location. يعني if my mass on the earth is equal to 60 kilogram, it means على المون عندي نفس الماس. بينما الويت no. The weight change according to where in the universe the object is. Now, in this example, I have a spring balance. In this spring balance, we suspend different masses. According to the mass, we obtain the weight. The first example is to complete the table. To complete the table, I need to convert the mass into from gram to kilogram. From gram to kilogram, then I will calculate the ratio of W over M. هون أنا بعتبر إنه أنا ما بعرف شو هي W over M. Now we will discover together what is the value of W over M. So we observe that the ratio W over M is constant. So W and M are proportional. W over M represent the gravitational field strength. Its unit is Newton per kilogram. This value change from place to another place. Yes, it changes since the J change from one place to another place. What is the relation between W and M? W over M equal J. If I do a cross multiplication, W will be equal to M times G. The second example is the reaction of support, R or normal reaction. يعني أنا هلا I record this video from my laptop. My laptop is on the table. طب ليش my laptop ما عم يوقع مع انه الويت عم تشده vertically downward؟ لانه في support في التيبل عم تعمل reaction بالعكس. دائما الرياكشن بتكون perpendicular على السبورت. يعني هون انا السبورت horizontal بتكون perpendicular عليها و these are other examples. Here the reaction of support, it's in this way. The second example and the third one. Okay, the muscular force, it's the force done by the any parts of the body, يعني الarms, the legs على الobject. The friction, it's the force exerted from the surface. بس يكون السيرفس rough. يعني بنلاحظ نحن منزحف على الجليد لأنه there is no friction. بينما على الزفت السيارة بتمشي منيح لأنه في friction تعمل slows down للموشن. وعند air resistance هي مثل الفريكشن done by the air على البادي. Other example or other types of force هي tension. The tension is the force exerted from a spring or string on a body. We will explain the tension in details in the second chapter. Okay, thank you.